Hello friends, welcome back to my YouTube channel. In this tutorial, I will be demonstrating you how you can perform paired sample t-test using EViews software. So now I am going to just explain the first question from the practical number 4. So here the title is paired sample t-test and simple regression analysis. So our aim is to learn about paired sample t-test and simple linear regression by using EViews software. So altogether we have 4 questions. Now the first question is for the paired sample t-test and this is for simple linear regression, and the third question is again for the t-test, paired sample t-test, and the fourth question will be again simple linear regression, right? So let's start with the first question. In this video I will explain completely about the first question, and later we will do the second question in another video, right? So here if you look at this one, in the previous video I just explained you how you can perform t-test for unpaired sample for 2 sample, right? So in the previous video we discussed how we can perform t-test paired t-test 2 sample t-test, right? So in this video we will be looking at the paired sample. Paired sample means, so earlier case we had 2 samples but the data points are not having any relationship, right? So for example, let me go to that one. Here this is what I already explained. This one, if you look at the fifth question, here the IQ test of 2 different departments, right? So now let's say this is A, this is okay. Now these are the people, right? So these are the IQ levels of people. Now let's say this is for Kumar, and this is for Kamal, and this is for, and so on, and this is for Fatima, this is for Muhammad, and so on, right? So here there are 2 samples, but between these 2 samples we have no connection. But here in this question we will have before and after situation, right? So if you look at this question, a psychologist wants to determine whether a certain type of running program will have an effect on resting heart rate, right? So now this is our objective. We have to test whether a certain running program has increased or decreased the resting heart rate, right? So the heart rates of 13 randomly selected people are measured. So we have selected 13 different people, and we are testing on these 13 different people in 2 scenarios: before we conduct the running program and after conducting the running program, right? So now the data set of the resting heart rate before the running program is given in the first row, and in the second row it has been given the heart rate of the 13 individuals after the running program was conducted on them, right? So now we have to now let's continue reading. They are then placed on running program and measured again 1 year later, right? So after 1 year we have received this data, right? So this is after 1 year. Now thus the before and after measurements for the each person constitute pair of observation. So you can see the word pair, right? So now if this is Kamal, this is the heart rate of Kamal before he received this running program, and after 1 year this is his resting heart rate, okay? So now what we have to do is thus the before and after measurement for each person observation, right? So now let's so the question here is, we have to test if the running program is effective or not. So we have to check if there is any difference between these 2 situations, right? So first let me enter the data into EViews software. So here we will open our EViews software and we will go to file, new work file, and here since this is not a time series data, this is just unstructured or undated, and let me name it as question 1, and the number of observations that we have is here 1 2 3 4 5 6 7 8 9 10 11 13, right? So I'm going to type 13 over here, 13. Okay, now I have to create two objects. So object, new object, right? So now the type of our object is series, and the name of the object is before, and okay. After that I have to create another object, new object. Okay, the type of the object is series again, and the name is after. Okay, right. Now I have to select these two objects. Now if you look at these objects, the objects are created in the alphabetic order. So when I am selecting, I have to select after and before, and again right click on it. Now I have to open these two objects as a single group. So after that I can enter the data values according to the question. So I have to edit it. Now let me just go to here, and I will just copy this and try to paste here, Control V. Oh. Okay, so let me close this. Oh, many series have been, because it is pasted in row wise. So let me just open these two as group. Now here 76. So let me just open this one, and I will simply. Okay. Now I can enter the data. Right. So here 76, 71. Here 76. 76, 71. 71, 72, 83, 72, 83, 72, 83. Let me, yeah, I have written in the book. '76, '71, '72, '83, '74, '77, '74, '77, '68, '74, '68, '74, '71, '75, '75, '76, '78. And then for after, we have 77, here 77, 74, 70, 74, 70, 77, 74, 77, 74, 68, 67, 68, 67, 64, 69, 77, let me, 77, 74, 70, 77, 74, 68, 67, 74. Here 74, 69, 71, 69, 71, 71, 73, 71. Now for t-test, now for paired sample t-test, we have to find out the difference, right? So the difference for each individual. Now we have to create another object, right? For that we have to go to quick, and now we have to generate a series, right? Now we are not going to create it, we are going to generate it using the equation. So we have to generate this equation using equation. Now we can enter this. Now we have to store the difference is equal to, now difference is our new object. Difference is equal to, we have to find out before minus after, before minus after, right? Before minus after. Now okay, after, okay. Now you can see here the difference, right? So I think I can delete all these no, series 1, these things. Okay, delete. Yes, 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 all. Okay. Now we have to open this difference, and now since we are going to perform the t-test on this difference, we have to check if this data set is normally distributed or not. If the difference data set is normally distributed or not, this is what we have to first check, right? So for this question, what we have to do is, we have to first check if the difference data set is normally distributed. For that, we have to write down our null hypothesis and our alternative hypothesis. So H naught, our data set, different data set is normally distributed, and HA, now let me write down here, H naught, the difference data set is normally distributed, and HA will be the difference data set is not normally distributed. So in EViews, we can simply perform our Jacobera test for this normality test. So I will just go to this descriptive statistics and histogram and statistics. So if you look at this p-value here, this p-value is greater than our alpha value, so we cannot reject our H naught, and hence we can conclude that our difference data set is normally distributed. Okay. Now we will just come to what we have to do for this question. So we have to check if there is any effect on the running program, right? So our H naught will be, now mu A is equal to mu B. In this scenario, there is no effect, right? So even after receiving the running program, there will be no effect. The mean of the heart rate, resting heart rate before situation, and okay, this is after situation. The mean of the heart rate, resting heart rate after receiving the running program, and the mean of the heart rates before receiving the before receiving the running program are equal. So here mu A minus mu B is equal to 0. So this mu A minus mu B is nothing but difference is equal to 0, right? So this is our H naught, and our alternative hypothesis D is not equal to 0, which means mu A minus mu B is not equal to 0. And from this we can tell our HA is mu A is not equal to mu B. There is a significant difference between the means of the heart rates before and after situations. So this is how we have to write down our null and alternative hypothesis. Now after writing the null and alternative hypothesis, we have to test the probability value. Now for that we have to go to this t statistic. The step for that is, now for this view, right? So now we can just look at the spreadsheet. Now for the difference data set only we are going to perform our t-test, right? So go to this view. Now if you go here, now under descriptive statistics you can perform this simple hypothesis test. So this is the steps that you have to follow, and here the mean value is, now you see here we have to test, right? So if you have only one sample, then the mean value will be specified. But here if you look at this scenario, here our mean value is 0, right? So here you have to look at this one, right? So for difference the mean value is 0. For difference the specified value is 0. So we have to type 0 here, and okay, and here this is the output that we have to consider. Now let me just insert this picture to format okay, and I will just insert this here. Let me insert this way. Right. So if you look at this output, now what we have to understand is, so hypothesis testing for the data set difference, right? So we have done our hypothesis test for the data set difference, and the sample we have 1 to 13, and we have included all the observations, and the test hypothesis or hypothesized mean is 0, right? Because we assume that H naught is equal to D is equal to 0, and D is not equal to 0, which means there is a difference between the two scenarios, right? Now here after writing it, now since we have t statistic, now this is the t value, the statistic value, but we have to consider this probability. Now p is equal to 0.0163. Since this is less than our alpha value, we will reject H naught. If we reject H naught, we will conclude that there is a difference between the two methods. Now we have to check which method is best, right? So if that is the case, now we have calculated this difference as before minus after, right? So this is what we have fed to the software. So this is our difference. Now before minus after is difference. So here if before is greater than our after, we will say that is p by 2, right? So this is p by 2, the probability value, because EViews software will give the probability value only for the two-tailed test, right? So if you consider this before greater than after scenario, this is a one tail but right tail, right tail test, okay? So here for one tail, the probability value for the right tail we have already studied in our previous practical also. Here here where is that? I should have explained. Right. So here for the right tail we get the probability as p by 2, right? So this right tail probability is indicated using this p1, and this is our two tail test. So p by 2 is our left tail test, right? So let me go here. Now here, this before, if we consider our HA is before is greater than after, then we will get this P by 2 as the probability value. So now let's consider this, right? So P by 2 means that is now P1 is equal to, for this scenario, for this alternative hypothesis, we have to check our P value. So this is P by 2 means 0.0163 divided by 2, that is equal to 0.0083, right? So now again this P value is less than our alpha value, so we will reject H naught, right? So if we reject H naught, what will be the conclusion? If we reject H naught, for this scenario H naught is difference is equal to 0, and our HA is before mean is greater than our after mean, right? So if we reject H naught, then we will accept our alternative hypothesis. So from this we can tell that after, right, so after receiving the running program, the resting heart rate has reduced, so the program is efficient, right? So this is what we can conclude. So this is how we have to construct our null hypothesis and alternative hypothesis, and from the P value we have to statistically conclude that the resting heart rate has reduced after conducting our running program. Okay, so this question is nothing, I just explained you the first question. Now a psychologist wants to determine whether a certain type of running program will have an effect on the resting heart rate, but here they didn't ask which scenario, so whether the before mean and after mean, before mean is greater or before mean is lesser. They just wanted to know whether the running program has an effect on the resting heart rate, right? So we can just conclude that the running program has an effect, the running program does have an effect, but the before mean is greater than after mean, which means the running program has reduced the resting heart rate. So biologically, if the resting heart rate reduces, then the program is efficient, right? So I hope you have understood this question, and I will explain you the second question in another video.